Prepare to have your mind blown. Imagine a cosmic entity so mysterious it challenges everything we know about the universe. Welcome to the enigmatic world of Gravastars, the mysterious cousins of black holes. Picture a massive celestial body, millions of times larger than our Sun, reaching the end of its life cycle. This star, having burned through its nuclear fuel, is now on the brink of a dramatic transformation. It's a cosmic drama that has captivated scientists and dreamers alike. The star's final moments are marked by a spectacular supernova explosion, a brilliant display of light and energy that can outshine entire galaxies for a brief period. We're talking about the collapse of a massive star, a celestial object far larger than our own Sun, as it exhausts its nuclear fuel. This process is not just a simple fading away. It's a violent and energetic event that reshapes the very fabric of space around it. Gravity takes over and the star implodes inward, collapsing in on itself. The core contracts under the immense gravitational forces, leading to a dramatic inward collapse. This implosion is so powerful that it can trigger the formation of some of the most enigmatic objects in the universe. The result? The traditional answer is a black hole, an object so dense that not even light can escape its gravitational pull. Black holes are regions of space where gravity is so strong that nothing, not even electromagnetic radiation, can escape from it. But what if I told you there might be another possibility, a strange and mysterious alternative to the black hole? Recent theories and observations suggest that the universe might have more surprises in store for us. What you think you know about black holes might be completely wrong. What if, instead of collapsing into an infinitely dense point, these dying stars transform into something even more bizarre? Imagine a scenario where the star's core doesn't just vanish into a singularity, but instead morphs into an exotic state of matter, creating a new kind of celestial object that defies our current understanding of physics. Scientists are now exploring these possibilities with advanced telescopes and cutting-edge research. The quest to understand the ultimate fate of massive stars is pushing the boundaries of our knowledge and challenging our perceptions of the universe. Enter the Gravastar, a theoretical object that challenges our understanding of gravity's ultimate triumph. While black holes are defined by their event horizons, points of no return beyond which nothing can escape, gravastars offer a different picture. They are, in essence, bubbles of exotic matter and warped space-time, held together by the repulsive force of dark energy. Imagine a cosmic balloon inflated by the very fabric of space itself, its thin skin a boundary between the familiar universe and the unknown depths within. To understand a gravastar, we must journey into its theoretical structure. At its core lies a region dominated by dark energy, the mysterious force that drives the accelerating expansion of our universe. This dark energy core exerts outward pressure, preventing further collapse. Surrounding this core is a thin shell of matter, the remnants of the collapsed star, compressed to an extraordinary density. This shell is what separates the gravastar's interior from the universe outside. Dark energy is a key player in the gravastar concept. Unlike gravity, which pulls things together, dark energy pushes things apart. It's this repulsive force that counteracts the inward pull of gravity within a gravastar, creating a stable structure that defies complete collapse. Imagine a tug of war, with gravity pulling inward and dark energy pushing outward. In a gravastar, these forces reach an equilibrium, a delicate balance that prevents the formation of a singularity. A thin veil of matter, the edge of existence. The thin shell of matter surrounding the gravastar's dark energy core is crucial to its existence. This shell acts as a barrier, separating the exotic interior from the external universe. It's incredibly dense, compressed by the immense gravitational forces at play. Think of it as a cosmic eggshell, protecting the delicate balance within from being disrupted. Gravastars versus black holes, a cosmic showdown. In the vast expanse of the universe, two of the most enigmatic and fascinating objects are black holes and gravastars. Both are born from the death of massive stars, but their characteristics and behaviors couldn't be more different. So, how do gravastars stack up against their more famous counterparts, black holes? To understand this, we need to delve into their fundamental differences and the unique roles they play in the cosmos. The key difference lies in their structure and the way they interact with their surroundings. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape from them. This is due to their incredibly dense core, which warps space-time to an extreme degree. Black holes are defined by their event horizons, points of no return. The event horizon is the boundary beyond which nothing can escape the gravitational pull of the black hole. It's like a one-way door to oblivion. Cross the event horizon and you're trapped forever. Anything that passes this boundary is doomed to spiral inward, eventually reaching the singularity at the center, where densities become infinite and the laws of physics as we know them break down. Gravastars, on the other hand, lack event horizons. Instead of a singularity, they are theorized to have a core of exotic matter, which prevents the formation of an event horizon. This makes them fundamentally different from black holes. While their gravity is still incredibly strong, it's theoretically possible for information and even objects to escape their grasp. This means that gravastars could potentially offer a way to study the extreme conditions of collapsed stars without the finality of a black hole's event horizon. The cosmic showdown between black holes and gravastars continues to intrigue scientists as they seek to understand these mysterious objects and their implications for our understanding of the universe. Echoes from the abyss, searching for gravastars. The existence of gravastars remains purely theoretical. We haven't yet observed any objects in the universe that definitively fit the description. However, astronomers are actively searching for signs of these enigmatic objects. One promising avenue is the study of gravitational waves, ripples in space-time caused by the acceleration of massive objects. If gravastars exist, they should produce distinct gravitational wave signatures when they form or collide with other compact objects. The future of gravastars, fact or fiction? Will gravastars remain a tantalizing concept, or will they one day graduate to the realm of confirmed celestial objects? Only time will tell. As our understanding of gravity, dark energy, and the universe's most extreme environments grows, we may finally have the tools to definitively prove or disprove their existence. The search for gravastars is a testament to the power of human curiosity, driving us to explore the universe's most bewildering mysteries. A universe of possibilities. The final word. The possibility of gravastars reminds us that the universe is full of surprises. These theoretical objects, which could be an alternative to black holes, challenge our understanding of the cosmos. They suggest that what we think we know about the universe might just be scratching the surface. It challenges us to question our assumptions about the nature of gravity, the fate of stars, and the ultimate destiny of the universe. Gravastars, if they exist, could provide answers to some of the most profound questions in astrophysics and the very fabric of reality. They could reveal new insights into the behavior of matter and energy under extreme conditions, offering a glimpse into the workings of the universe at its most fundamental level. Perhaps lurking out there in the vast expanse of space, beyond the reach of our current technology, these cosmic bubbles of dark energy and warped space-time await our discovery. They could be the key to unlocking new realms of knowledge and understanding. The search for gravastars is not just about finding new objects in the sky. It's about expanding the horizons of human knowledge and pushing the boundaries of what we believe is possible. And if we do find them, it will surely revolutionize our understanding of the cosmos and our place within it. The discovery of gravastars would mark a new era in astronomy, one where the mysteries of the universe become a little less mysterious, and our quest for knowledge takes us to new and exciting frontiers. As we conclude this journey into the enigmatic world of gravastars, remember that the quest for understanding is never-ending. Each discovery, each theory brings us one step closer to unraveling the grand tapestry of the universe. Thank you for joining us on this cosmic adventure.